Elements, compounds and mixtures. Today we will begin this chapter. What do you think are elements, compounds or mixtures? You can write it down, whatever comes to your mind about these words, elements, compounds and mixtures. Even a very important question. Why are you studying elements, compounds and mixtures? What is its significance? Is it only because it's there in your syllabus? Or there are some more bigger reasons? Jot down whatever you think may be the possible reason for studying this chapter, though you may not have an idea about what this chapter is all about. So you may be wrong, don't worry, but still, whatever comes to your mind, write it down first and then we can begin the chapter. Now, scientists like to classify things. Whatever they see around us, they have this tendency of classifying them into different groups. So they did the same thing with matter. They classified matter on the basis of its composition. And when they classified matter on the basis of the composition, they found that there were various types of matter. Matter differed from one form to another, from one another on the basis of their composition. So what we are going to study is, we are going to study about these different types of matter which scientists has classified into, and their classification here is based on their composition. Now when we classify matter into two broad categories. One is pure substance and the other is mixture. Mixture is also known as an impure substance. A pure substance is further classified into elements and compounds, while a mixture is classified as homogeneous and heterogeneous. And elements are classified as metals, non-metals, metalloids and inert gases. As we progress with the chapter, we will learn about each of these things in more details. So let's begin. We will begin a journey with the pure substances. So what is a pure substance? A pure substance is one which has a definite composition. That means it is made up of a fixed number of atoms, maybe molecules. Whatever it's made up of, that's defined. It cannot vary. That today water contains hydrogen and oxygen. Tomorrow water will contain hydrogen and nitrogen. Maybe day after tomorrow it will be oxygen and nitrogen. No such things can happen. It has a definite composition. That means if water is made up of hydrogen atoms and oxygen atoms, that too, two hydrogen atoms and one oxygen atom, if you take, it will always be made up of two hydrogen atoms and one oxygen atom. And you go around wherever you collect water from this world, the composition of water will be fixed. That's two hydrogen atoms and one oxygen atom in one molecule of water. It's homogeneous in nature. Now the next property. It has a definite set of physical and chemical properties. What is a physical property? Can you remember from the previous chapter? A physical property is the shape, size, color, state of matter of a substance. Even the melting point, boiling point, solubility in water, odor, all these things come under physical property. So if you take a sample of water, a water is in liquid state, is a liquid. So it's the physical property of water. A water freezes at 0 degree centigrade. So its freezing point is 0 degree centigrade. So freezing point is a physical property of water. Water boils at 100 degrees centigrade to form steam. So boiling point of water is a physical property of water. So any pure substance will have a definite set of physical and chemical properties. That means if we are saying that boiling point of pure water is 100 degrees centigrade, it will always be 100 degrees centigrade. It cannot change, and sometime it can't be that the boiling point of pure water becomes 110 degrees centigrade. Sometimes the boiling point of water becomes 90 degrees centigrade. Such things cannot happen. And that's what we mean, that a pure substance will always have a definite set of physical properties. Such things can happen with an impure substance, with a mixture. The physical property and the chemical properties of the mixture will be variable. They cannot be definite. It can keep on changing depending on how much quantity is present, but it won't happen with physical properties. And when we talk about chemical properties, we talk about its behavior with different type of acids or chemicals, how it reacts, how it burns in oxygen. All these things come under chemical properties. So how it reacts with other substances. The properties of a pure substance cannot be changed by physical methods. So you can't use any physical method like maybe just heating and you change the properties of a physical pure substance. Elements. Now what are elements? An element is a pure substance which is made up of only one kind of atom. So an element will always have only one type of atom. So let's see. Here we have two pictures. First we will consider the picture A. In picture A, each of these circles represent an atom. Now all these circles, you can see they have the same color. So what we want to show you, that all these atoms are same. They are similar in nature. They are of the same substance. So that's what we want to show you. So substance A is made up of atoms and all the atoms are same. So A is an element. In substance B, we have two atoms which has combined together to form a molecule. Okay, so substance B is made up of molecules, while substance A was made up of only atoms. But in substance B, though there are molecules there, the molecules are made up of only one kind of atom. So take any of the molecules, you will see two yellow circles are there, which are joined by a single line. That single line shows that they are joined together, they are one unit, they have formed a molecule. So but basically what you have two same type of atoms forming a molecule. So substance B is also an element, substance A is also an element. An element cannot be converted into anything simpler than itself by any physical or chemical process. So if you can't break down an element and get something else which is more simpler than the element. We have some examples here: sodium, calcium, nitrogen and helium. So this is mercury, a sample of mercury, an element here, a liquid metal, and this is a sample of copper, another element here. Now the picture which you can see is cesium metal. This metal, if it is taken in your palm, the heat will be enough to melt it. It's usually solid, but at a low temperature. If the temperature starts increasing, it changes into liquid, and it's a highly active metal. Now we are trying to study the properties of metals. Metals are usually solid at room temperature. Few exceptions are always there, like mercury, gallium. These are usually liquid metals. Cesium also ends up becoming liquid at a very low temperatures. Lustrous. They are lustrous, that means they have a shiny appearance. They are good conductors of heat and electricity. So some more example of metals here: sodium, copper, mercury. These are the examples of. Now you have an activity. You pause the video and take a exercise book and write the name and symbols of as many metals as you can, without referring to any other place. From your memory, try to write down the name and the symbols of as many metals as you can. Now we move on to the next type of pure substance, that's a non-metal. So what is a non-metal? A non-metal can exist as soft solids, liquids or gases. And here is a picture of a sulfur, a piece of sulfur. You can see it's not pure, but that's how it looks like. They are non-lustrous. They don't shine, they don't have a shiny appearance, they are dull. They are bad conductors of heat and electricity. So carbon and oxygen is also an example of a non-metal. And here we have one more non-metal for you. This is a phosphorus. That's a sample of phosphorus here. Now we have activity 2 for you. Again, pause the video. Write the name and symbols of as many non-metals as you can. And then find out of the 118 elements which we have discovered so far, how many are metals and how many are non-metals. Metalloids. Now there are some elements which show some properties of metals and some properties of non-metals. They are usually solids and hard solids. So arsenic, antimony, bismuth, germanium, these are the examples. These type of elements which show some properties of metal and some properties of non-metal are called metalloids. So arsenic, this is an example. You have a picture of an arsenic, how it looks like, and you have antimony, another picture of metalloid. You would have heard about arsenic a lot in the news if you follow. In many areas in West Bengal, there is arsenic pollution. The groundwater is polluted with arsenic, and if people end up drinking that groundwater, using it for various purposes, they end up getting skin diseases and due to arsenic pollution. So arsenic pollution is a major issue in many areas in West Bengal. Noble gases or inert gases. They are chemically inert. So there are some gases which are chemically inert. They do not undergo any reaction. They don't react with anyone easily. And they exist as atoms. They don't form molecules. Such elements are called noble gases. There are only 6 noble gases: helium, argon, neon, radon, krypton and xenon. These are all the 6 noble gases. But xenon does form a few compounds with oxygen and fluorine.